speakers who are students at the NKS Summer School. The NKS Summer School is a 3-week program, and everybody came with maybe an idea of what they wanted to do, but the projects were developed in the first week, and for the last 3 weeks they've been working on these projects, so these are sort of works in progress. And they've had some exciting results, and you can see the posters that have been set up. And our first speaker is Deathwood.
Okay, I'm going to try not using this. Can you all hear me? Okay, the first thing I'm going to ask, because it's getting kind of late, is if I've got a little demonstration I want to do that's very NKS, but everybody's going to have to move closer to the front center. So if you're in the back, if your neighbor is asleep or something, if you could just stand up and move a little closer and sit down in the center. I was told this was an awful idea, so I wanted to try it. That includes everybody, so I know I'm okay asking the MKS people to do it, but I like everyone to, for the purpose of this demonstration. I'll wait. And you need to be near at least one person for this. So what I would like for you to do, what I'm going to talk about is how equilibrium forms from simple rules. This is probably one of the coolest things I've ever seen. Is there anyone that can't snap their fingers like this? Is there anyone here? Okay, then can you click your tongue? There you go. Okay, when you click your tongue, everybody else can snap their fingers. What I want for you to do is I want you to randomly just snap, not yet, just give me a sec to explain. I want you to randomly snap your fingers and try not to really be, try not to have the same pattern as anyone else. And then when I say go, all I want you to do is I want you to try and slowly match your neighbor. And then if you all feel like you're in sync, I want to see if you can match the people around you and see if any patterns emerge or if we can equilibrate somewhat quickly. So if you would, I'd like everybody to just start snapping kind of randomly. Try and be as random as possible. Okay, now I want you to start sounding like your neighbor. Now I'll start sounding like the people around you. Okay, we're not very good at this. Usually, if you have enough people in the room, you'll start to form one big pattern, and in about 10 seconds, you'll start all going at the same measure, but I think we're all kind of tired, so I'll just go from there. All right, I only have a 7-minute talk, so it shouldn't be too hard, and I don't have many words. And I'll try and speak somewhat slowly because I know not English isn't everyone's first language. So my model that I'm going to look at is a multi-state rule-based aggregation model and the equilibrium states that form because of it. I've made this over the course of 2 weeks at NKS. There's not much text, so I'm really just going to show you the rules, the results, and when I think it could be applied. So the basic rules for this system is that I take some random initial condition and I look at what the majority of things are doing. So for this, the right arrows and the left arrows cancel out. The up arrows and the down arrows cancel out. So if I sum my 8 neighbors for this first case, what I'll have is I've got 4 to the right, 2 to the left, 1 up, 1 down. So my net magnitude is 2 to the right. So what I'm going to do is I'm going to change my center cell and have it go to the right because the net magnitude is to the right. It's the greatest net magnitude, so that's what I'm going to choose. This next type of system I'm going to look at is where I have a threshold. And what that means is that if the net magnitude isn't larger than the threshold, what you're going to do is just assume a null state. And I'm going to say that, so that means there's no real value there. It's just a null. It could be a 0 or something. So in the second circumstance, it's the exact same conditions we had as before. But this time, I've got 4 to the right, 1 up, 1 down, 2 to the left. So my net magnitude in the up and down direction is 0. My net magnitude in the it didn't surpass my threshold. So it's going to become an equilibrium cell, which I'm going to represent as this little square right here. So in full MKS fashion, the best thing to do for a system like this is to just make an experiment and try it and see what happens. Because if I did something like that, you might not really know what's going to happen, and if you can, you're a computer. So what I've done here is I have a pretty simple problem where I've made all left arrows on one side, all right arrows on the other. So those kind of act like sources for things to propagate from. And then I put periodic boundary conditions in the up and down direction so that these top